Hey everybody, Dr. Segan here, and today we're going to do a video lecture that is about environmental economics. So basically how the environment influences economics and how our economic system depends on the environment. And this is probably the topic that I've thought about the most and how my perspective of the world has changed the most in the last year. So it should be pretty interesting as we get into it. The first part is pretty simple. It's talking more about how we put a value on Earth's natural resources and also what it does for us. So Earth does a lot for us. It provides us with water and air, land for food, soil, fish, and all kinds of stuff. So putting a value on that, that's kind of the first part of environmental economics. And then the second part is how our economic system is actually influenced by the environment and in particular natural resources. So let's get right into it. Our topic here is environmental economics, and I think usually these two things are kind of pitted against each other. So for example, when we poll voters in America, generally speaking, they put economics near the top and they don't prioritize the environment nearly as much as economics. This is the most recent 2020 poll. And if you're confused by these numbers over here, if you start adding up the percentages here, you see that it begins adding up to over 100. This is the voters basically rank their top 3 issues, and this is the percentage of voters where this issue was in their top 3. So 49% of voters had coronavirus in their top 3 this year. That makes sense. Obviously, it's had a huge impact on all of our lives. The economy and unemployment, I think those two things kind of tied together. You know, with the coronavirus pandemic raging, a lot of people lost their jobs because we can't do what we used to be able to do, et cetera, et cetera. And there's less demand for lots of activities that used to employ people. So regardless, pretty much number 1 and number 2 involve the economy. Healthcare, usually that involves cost, and so that's linked to the economy as well, that you're talking about whether or not people can afford healthcare, and so we're talking about money there. So really the top 3, I would say, are kind of all related to the economy, jobs, whether or not people feel like they can afford things. Whereas the environment and climate change is ranked way down here at number 10. It used to be ranked down way, way further. I remember probably 10, 20 years ago, usually the environment ranked in the 20s or even lower than that on these sorts of polls. So really, generally speaking, the environment is not considered all that important to the average voter. I did look a little bit more into detail. I think this was a Pew or maybe a Gallup poll. For people under 30, the environment was in the top 3. So pretty much the older you got, the less you cared about the environment. But regardless, the average voter does not care very much about the environment compared to the economy. What I've kind of learned this year is that those two things are really pretty much related and are kind of similar. The environment and the economy are more interlinked than most people realize. And I'll give you some examples as we move through this. So the basics of environmental economics. So generally speaking, when people talk about environmental economics, what they're talking about is basically trying to quantify the value of Earth's ecosystem services. And what we mean by an ecosystem service is basically something that Earth does for us that benefits us, economically or otherwise. So for example, coral reefs are estimated to provide about $500,000 per year per hectare of coral reef. A hectare, I think, is like a big soccer field. So if you have a big soccer field of coral reefs worth of this really rich ecosystem, it can be worth around $500,000 per year So every year it's worth $500,000 just to have that coral reef around. And you might be asking, how is that possible? Well, coral reefs do a lot of things. They're the base of the food chain and provide habitat for all kinds of fish that we eat. So all of the money that we make from fishing and all the food that we provide from fishing, all that basically comes from coral reefs. A lot of it comes from coral reefs. So that's worth obviously some moolah there. Coral reefs, if you have them built next to a coastal community where you have homes and things nearby, if you have things like storms and tsunamis, what happens is that as those big waves come crashing into the shoreline, if you have coral reefs, they kind of get broken up before hitting the house, whereas if you don't have coral reefs, the wave makes it all the way to the house. So coral reefs also provide storm protection to homes. And obviously, if the home is destroyed, you lose money. So here you got some more money here that we're making off of this coral reef. And then, of course, lots of people like to go to coral reefs for tourism. They like to snorkel. So there's money to be made for the community there if you have a tourism industry. So all of these things, if we try to total up how much we think they're worth for a coral reef, it comes out to be a lot of money, $500,000 per year per hectare. And so this is generally speaking how environmental economics works. You think about how much things are worth, and then we can kind of put a cost on things like pollution or climate change or global warming that are destroying these ecosystems. That's sort of the idea. And we can kind of use the same type of methodology to give an idea of what is the total worth of all the ecosystems all around the world that basically help humans out. And so there we're talking about all the fish and seafood that we get from wetlands and oceans and coral reefs, all the forests that provide us lumber and fuel and building materials, all of the coastal ecosystems that provide us with storm protection, all of the tourism, even stuff like, bees for pollinating our crops, soils and bacteria that can help kind of restore and let us grow more crops, all that stuff. Purifying our water, you can see all kinds of different services over here on this wheel, food, yada, yada, yada. All of those things, if we try to add up all of the value there, some scientists have kind of worked on it, and the general estimate is something like $30 to $100 trillion per year. That's a huge number. Trillion, if you need a refresher on what these numbers mean, 1,000, I think we all know. If you do 1,000 times 1,000, that's a million. If you do 1,000,000 times 1,000, that's a billion with a B. And if you do 1,000,000,000 times 1,000, that's a trillion. So we're talking about $30 to $100 trillion. So that's an absurd amount of money. And as a reference point, the total global economic output of all humans, basically all around the world, every country, is something like $85 trillion per year. So all the stuff that we make, produce, all the services that we do, all of that is supposedly worth something like $85 trillion per year. So you can see this is kind of comparable here. So the entire economy, we basically get the entire economy's worth of output just from all of these benefits that ecosystems provide us. So if we destroy all these ecosystems, the idea is that we're almost destroying the equivalent of our entire economy in the process. So we really should protect them. That is generally how environmental economics is sold. All right, but we can take that actually a step farther, I think. I think when you talk about ecosystem services, you're actually short selling everything that the world actually does for humans. Yes, we're quantifying things like how much food we get from seafood and how much storm protection for our houses, but are we really quantifying like how much it's worth to be able to continuously, breathe oxygen and to continuously have our water recycled through the water cycle, things like that. And putting a value on, okay, what is the worth of recycling oxygen and water back to 7 going on 8 billion people around the world. How do you actually put a cost on that? And there is kind of a way to think about this that I think is interesting. And the way you can kind of do this in terms of quantifying the actual worth of basically the world, the Earth, to us is something called a replacement cost methodology. So basically, if we think of this ecosystem on the right, this is called the coastal sand dune ecosystem. And this is actually the ecosystem that I studied to get my PhD. And part of what I did in my publications and my research was I researched how much these were worth in terms of storm protection. So how much money they were worth in terms of storm protection. And actually, if you want to check that out, you can Google my name in Google Scholar. That's the scientific publications. And Steve Seagren Coastal Dunes, you can see all these articles pop up. And one in particular, this one in particular, actually I put a value on coastal dunes that came out to be something like $8 million for the entire dune ecosystem of Galveston during one storm. So anyway, yes, I'm very comfortable talking about this topic because that was actually what my research was on. But back to this replacement cost methodology. So we have these sand dunes. Let's say these sand dunes went away and we didn't have them anymore, and people ran over them with their trucks or whatever. They polluted them and they got destroyed, or they cut off the sand supply, whatever. And we wanted to replace this barrier. So basically how a sand dune works is that there's a big mound of sand here, and when storm waves come crashing in during a big hurricane or something, they have to kind of crash through and break up this sand dune before they reach these houses. And so they offer some protection in the process. So if we want to replace the sand dune with a man-made structure that could do the sand dune's job, we would basically need to build something like this, which is a seawall. So how much would it cost to basically build a seawall here instead of using these natural sand dunes? And seawalls can get really expensive because you have to bring in rocks or concrete or something. So that is one way to estimate how much something is worth, is basically how much would it cost to replace this with a man-made structure. So can we do that with the entire Earth? Yeah, kind of. I recently assigned for my class this assignment where you had to ponder what life would be like on what's called a generation ship. This would be a ship that was designed to basically carry humans to another solar system, which is really, really far away. It would take hundreds, if not thousands of years. And the idea with a generation ship is that the original astronauts that depart Earth are not going to make it to the next solar system. And instead, it's going to be their children or their grandchildren or their great-grandchildren. They're going to basically live and die on this spaceship. And in the process, basically, you're going to kind of have like an artificial Earth that you have to carry along with you. And this generation ship would have to do everything that Earth does in terms of recycling your water and your oxygen and providing you with food and recycling your waste and doing all those things. So we could ask ourselves, if we wanted to make a replacement for Earth, basically it would look something like this. Some spaceship that could do all the things that Earth actually does for us. Is there any possible way that we can approximate how much such a spaceship would cost? Well, we technically have a spaceship in orbit right now that is, I guess, our closest thing to a generation ship, but not really quite. It's the International Space Station. International Space Station usually houses something like, I think, 4 astronauts or so, and they actually live in outer space for an extended period of time before coming back to Earth, and they're always kind of cycling in and out, and they carry out all kinds of different scientific missions up there. Occasionally, you can actually see this crossing the night sky as it orbits Earth. And on this International Space Station, our most complex satellite and pretty much our most complex spaceship that we've ever built, it actually does some of this stuff that Earth does. For example, water recycling and oxygen recycling and waste recycling and food, energy, all that stuff. So we can compare basically what this spaceship does compared to Earth, and we can think about how much it costs to build this spaceship and how much it would cost to build a spaceship that could actually hold all 7.9 billion people living on planet Earth. So let's talk about this. Earth, we know it provides us with water. So basically, you drink water, you pee it out, you sweat it out, it goes into the rivers and oceans and atmosphere, and then all of that water turns into clouds and rains back down. And so all of the water that we use is constantly recycled by the Earth. So it does an amazing job recycling our water. The International Space Station also has a water recycler. I think it's about 93, 94% effective. So basically when the astronauts pee, or they breathe out, or they sweat, all of that water is actually reclaimed by the space station, and they are actually drinking their own, recycled wastewater, which is the same as what we're doing on Earth. If you go back and watch I think it was the carbon and nitrogen cycle video, I talked about how everybody is constantly drinking everybody else's pee on Earth because those water molecules work their way to the ocean and then back into the clouds and then back down as rain, and then we drink them again. So the International Space Station does that really well. Oxygen recycling, it does not really do at all. Pretty much all the oxygen on the space station comes from water that is split apart using electricity, but it is not recycled. So once the astronauts use up the oxygen to produce carbon dioxide, the carbon dioxide is released out into space, and they have to constantly bring in new oxygen. So it technically doesn't do oxygen recycling, whereas on Earth, we have forests and plants that will constantly recycle and keep the oxygen amount stable in our atmosphere. Waste recycling. The International Space Station does recycle some of the water in our waste, but it does not recycle those nutrients that are lost, like nitrogen and other trace nutrients. All of those things basically get recycled back into the soils and water and life forms here on Earth, because we have this robust bacterial community that does all that stuff. We have all these decomposers breaking down waste and dead materials and poop and pee and all that stuff. So I'll give it a check minus on that. It's not quite as good as Earth. Earth provides us with an abundance of food and land to grow it on. The International Space Station does not have that. All the food has to be brought in from the outside, so they don't have any kind of farm or anything like that on the space station. Energy, yes. International Space Station has all of the renewable energy it needs from the solar panels. Like I said, the inhabitants of the space station are only 4, I believe, compared to the 7.9 billion on Earth. And the cost of the International Space Station is something like $100 billion. That's how much it costs to make it. So what does that leave us? Our Earth, our planet, basically does all of these things perfectly for us, and provides food for all the people on Earth. Provides us not only with sunlight and renewable energy sources, but also tons and tons and tons of non-renewable energy sources that we can build our lives around. Of course, it inhabits way, way more people. So what would the cost be? Well, you can take this cost, which is $25 billion per person, to basically do all this stuff in space, but not as well. If you actually wanted to build a spaceship that could do its own food growing and oxygen recycling with plants, like you'd have a full-on farm that could recycle oxygen and also grow food, and bring that aspect of the Earth's biosphere with us, I would think that would cost easily another 100 billion, maybe more, to establish that on a space station. And so what we're looking at is something like $50 billion per person is what Earth is worth to us in terms of its just ability to do all these things that we take for granted. And if you take 50 billion times the 8 billion people that are here, the value of Earth isn't just some 30 to 100 trillion dollars in ecosystem services per year, but in terms of replacement cost, it's in the, not even in the quadrillions, it's not even in the quintillions, it's in the, you're getting into the biggest numbers possible. So in other words, if we're trying to talk about what is the actual value of the environment and the earth and all the things that it actually does for us, it is infinitely valuable, especially if it's not only going to house 8 billion people now, but the next generation of 8 billion and the next generation of 8 billion and the next generation of 8 billion, hopefully forever. So when we're trying to debate what's more important, the economic system, whether or not you have a job, or the environment and having a habitable planet, there is no competition, not even freaking close. And any aspect of the economy that is actually harming the environment, and in particular the environment's ability to recycle water so places don't have droughts or extreme flooding, and recycle oxygen so we're not destroying our forests, and recycle waste so we're not just destroying our oceans by dumping a bunch of trash and stuff in it, and degrading our soil so that we're no longer going to be able to grow food. Any of those things that damage those aspects are completely not worth it, even if it provides somebody a job, because it's going to kill everybody eventually. That's sort of the big takeaway here. And that reminds me of a quote that's attributed to some ancient Native American proverb, although it's actually attributed to this a Native American in Canada, Alanis Obumsawin. Not sure how you say that. One particular Native American in Canada, but you might have heard of this quote: "Humanity operates on a depletion economy, which leaves destruction in its wake. Your people are driven by a terrible sense of deficiency. When the last tree is cut, the last fish is caught, and the last river is polluted. When to breathe the air is sickening, you will realize too late that wealth is not in bank accounts and that you can't eat money." Pretty deep stuff. All right, so that's conventionally what is, I would say, kind of regarded as environmental economics. So kind of trying to study the value of the environment from an economic standpoint. And that's a very interesting topic. And I think it's pretty easy to grasp when you put it in those terms. A topic that I've become completely fascinated with, in particular this year, has been how our current economic system is completely reliant on natural resources, and in particular, non-renewable natural resources. So these are things that we're going to run out of one day. And everybody knows we're going to run out of it. And I've known it for years, but I've never really thought much about what it's going to look like when we begin running out of natural resources. And maybe it was just the pessimistic attitude I had all year with the pandemic and all this crazy climate change stuff that's happening, that I started thinking, oh, maybe that's already starting to happen. And I started kind of digging into it. And I'm pretty much convinced that the current world we're living in is already a depleted world where we're beginning to run out of non-renewable resources, and a lot of the crazy stuff that's happening in the world is a result of that. I feel a little bit crazy when I start talking about this topic and thinking about it. I feel like I need to break out the yarn, start screaming about Pepe Sylvia.
You want to talk about stress? You want to talk about stress? Okay? I've stumbled onto a major company conspiracy, Mac. How about that for stress? What the hell are you talking about? This company is being bled like a stuck pig, Mac, and I got a paper trail to prove it. Check this out. Take a look at this.
Jesus Christ, Charlie.
That right there is the mail. Now let's talk about the mail. Can we talk about the mail, please, Mac? I'm dying to talk about the mail with you all day, okay? Pepe Sylvia. This name keeps coming up over and over again. Every day, Pepe's mail's getting sent back to me. Pepe Sylvia, Pepe Sylvia. I look in the mail. Well, this whole box is Pepe Sylvia.
But as far as I can tell, it's actually really what's happening. And it kind of completely changed my perspective on the world, on the economic system, on just about everything. So yeah, I'm gonna kind of explain some things to you about this new topic that I've been learning about. So yeah, going back to kind of how we started this lecture, where we were talking about voters and how everybody cares about the economy. And rightfully so. I mean, we care about having jobs, being able to maybe retire one day, being able to afford things like, food and a place to live and maybe having a car and having a few nice things. Everybody kind of wants that. And it seems like, certainly in my lifetime, I'm 30, so I was born in the late 80s, and I experienced the 90s and 2000s and the financial crisis of 2008, and then the, I guess, partial recovery to that before the pandemic happened, and definitely feels like, from my perspective, just kind of driving around, that the economy and the economic well-being of people in this country seems to be getting worse. Most underpasses, you can see tents of homeless people living now. And it was that way before the pandemic. It's just gotten a lot worse. Businesses closing, all this stuff. And I think you kind of just grow to accept it over time, and you don't really think too much about it. But I begin kind of questioning more and more, like, why is this happening? I think probably before this year, and I think it's technically still true, you can talk about income inequality and wealth inequality and how much the rich have and how they're getting richer and richer over time, or getting poorer and poorer. And I think that's absolutely true, and that's a huge part of it. But I never thought about environmental science and natural resources as potentially the root cause of this. And let me just kind of walk you through some of the things that are happening to our economy. The first thing is, if we look at how much the economy is growing as a percentage each year, we see that this is actually trending downward. So how you read this graph is, here's a year, 1965, 70, all the way over to 2020. If you're below zero on this graph, that was a year where the economy actually shrank. So the amount of, and when we mean the economy, we use the term GDP, which is basically how much stuff people are producing and purchasing. That's generally how we measure the economy. So on years where you're below zero down here, these are actually years where the economy shrank compared to the previous year. So it wasn't as good as the previous year. And everywhere above this, up on this side of the graph, that is a year where the economy grew compared to the last year. So you can see that there's more growing going on than shrinking, but the overall trend line is going down. So we used to have really crazy growth, like 4 to 5% back in the 70s and into the 80s, and then it was more like 3% into the 80s and 90s, and then now, yes, it's still growing, but when it does grow, it's not by very much, and the plunges it takes when it doesn't grow are getting much, much bigger. And so the overall trend is downward. If we were to think about the actual economy, it was growing kind of exponentially, and then now it is basically slowing down and kind of flattening. So it's still growing, it's just not growing as much if we were going to look at the overall trend in GDP. So that was something that I had never really looked at the data for, and it's a bit alarming because, like, if this keeps going on and we keep trending down this way, within 10, 20, 30 years, we will basically be at zero growth. So what does that mean? If the economy is not growing, the amount of goods and services we're producing is not growing anymore, that means that the amount of stuff that we have isn't growing either, and presumably that means that life isn't really getting much better for the average American. So that doesn't sound good, and that seems to be what's happening more and more. At the same time as the economy is shrinking, if we look at the total debt of the government, we can see that it's basically exponentially increasing. So as our economy is flattening and weakening and slowing down over time, our debt is doing the opposite. It's basically just starting to go straight up, like so. So that's a bit alarming, because this is all money that theoretically has to get paid back by, I mean, generally the way you pay back debt is by growing the economy. So if the economy grows enough, you take in a lot of tax revenue for the government, and then that tax revenue pays off the debt, and the debt will go back down, like so. But if the economy doesn't grow, and if this trend continues, then we just have to keep on taking more and more debt. And how does that end exactly? Okay. This is actually kind of what got me
Pepe Sylvia, Pepe Sylvia.
learning about this topic in general. During the pandemic, everything was shutting down. The economy was projected to contract by the biggest amount since the Great Depression, and it was going to contract pretty much all around the globe by that amount, which is the biggest economic downturn ever. And at the same time, the stock market was just completely taking off, and the stock market's at like all-time highs. And I was like, how is this possible? And it led to me this term called quantitative easing, which is essentially the government or the central bank, which is sort of half government, half bank, essentially can just print money and give it to banks and corporations.
Simply flooded the system with money.
Yes, we did. That's another way to think about it. We did.
Where does it come from? Do you just print it?
We print it digitally. So we as a central bank, we have the ability to create money digitally, and we do that by buying treasury bills or bonds or other government guaranteed securities, and that actually increases the money supply. We also print actual currency.
I wasn't even aware that this was happening, and it really didn't happen basically at all until the 2008 financial crisis, in which case it began, again, essentially just going straight up at that point. So that led to me all kinds of things like, wait, how can we just print money out? And that's actually what's going on. I mean, that's it's like unbelievable.
Pepe Sylvia, Pepe Sylvia.
Because generally speaking, if you're having to print a bunch of money, history generally shows that doesn't work out too well for countries. So yeah, that kind of rabbit hole of, wait, what is going on with the economy kind of led me to all of this stuff that I learned. So yeah, the amount of money that's being printed is exponentially growing. The amount of debt that's being taken up is exponentially growing, yet the economy is declining. Okay. This is also crazy to me because, the prospect of retiring, I'm hoping to, maybe retire by like the time I'm 65 or something like that. But based off the current trends, that ain't going to be happening for the average American. I couldn't believe that in the 90s, the average person could retire at 57, 58. And then that trend's also going up. I don't know what it is currently in 2020. But obviously, if that trend keeps going up, my idea that I'm going to retire somewhere in 30 or 35 years, ripe old age of 65, is probably not going to hold up. So, yay, that sounds fun. This is another pretty troubling graph. The amount of people that are working, and these are people that are eligible to working. So you're taking out the elderly, and you're taking out people, I think, underneath the age of 16. And what we're seeing is that throughout most of the 60s and 70s and 80s and 90s, the number of people that are working in the economy is going up and up, which means that there's more and more jobs for people. And generally speaking, I would say that's a good sign for an economy. And then somewhere around 2000-ish, the trend started going down. So now we have fewer and fewer jobs proportional to our population. And the trend is actually the opposite for people that are 55 and older. When everybody else was having trouble finding jobs, older people are actually working older and older. Basically, more and more old people are working because they can't afford to retire. So that's okay. That's not a great trend here, economically speaking. So again, it just kind of begs the question, like all of these things just look terrible. And none of these things were pretty much happening when I was born, late 80s. I mean, things were going really well. So what is going on?